So, hello everyone. Today we are going to start with a new topic that is operating systems. And this is also one very important topic. Last time also there were questions from the operating system and direct theoretical based questions was there. So we have just finished two topics, that is communication as well as the data structure. Now we are jumping into the third topic, and maybe two, three videos on this topic will be uploaded. So there is a Telegram channel, t.me slash APDCIO2025. Search this and join this. We are uploading the lectures as well as the notes that we are going to make today itself during the video recording process. And we'll be uploading it on the channel. So please join this channel. And yes, before starting this topic, let us just see what are the contents that we are going to cover in this entire topic. First, we will be covering like the basics of the operating system, basic of the operating system. Then we are going to cover about the detail about what is a process. Then we will move about the memory management, memory management. Then we will have like the input output management is there. Then we have file. Then what else? We are going to cover small details of the protection and authorization or security, whatever you want to say. So these are the topic that we are going to like cover. So these are the broader prospect that I have given you. So basically, there are different terms and different algorithms that we will be seeing in this entire process. So what is an operating system? Starting from the operating system, what is it? So generally, we in our laptops or in our desktop, we are using the Windows operating system, or some of you might be using the Linux operating system. So what does it do? See, we have a hardware and we have someone in this middle as an interface, and then we have different software applications. Whether you say as the VLC media player, or you say as the audio recorder, or you say any MS Office or webcam, or you say any other application, website or any other application. So you have given a hardware like you have a laptop in which there is a CPU and there are other storage and everything is there in the hardware. And there is someone in the sitting in between the hardware and the applications that are running on it. And that something or that interface is known as the operating system. So basically, it manages the hardware one side and software on the other side and act as an interface or a linking interface between these two. So this is the basic of the operating system. It act as a bridge. Suppose we as a user are directly interacting with this. We are interacting with the VLC media player, which uses the speaker, which is the hardware of the computer or the laptop. So basically, it is acting as a bridge between the user and the hardware. So what function that is performed? It performs the following six functions. So operating system that manages the hardware and software resources and act as a bridge between the user and the hardware. So let us see what function does it perform. First of all, it has the input output management function. Then it has the file management system. So we will see the detail of each of its function. Just note it down the different functions. So input output management system, file management system. Then we have the process management system, process management, or then we have memory management. Then we have the like resource allocation, and we have the security and protection. These are all six different types of the functions. So in the questions, if there is written the which of the following is not a function of the operating system, and compilation is given as one of the option, then compilation is not a function of the operating system. So what else are the function of the operating system? We have seen just above. It is the file management. It is the IO management. It is the process management, memory management. Then we have the security and protection and resource allocation. Okay. So what are the different types of operating system that we have? we have like the batch operating system, we have the time sharing operating system, real time operating system. See, real time operating systems are basically embedded system. These are basically embedded systems. Okay, the real time operating systems are basically embedded systems. Then we have a distributed operating system, multi-programming operating system, and multi-processing operating system. So when we have a real-time application, such as we have air traffic control, which type of operating system will be used? It will be used as a real-time operating system. So these are basically the different types of operating system. So these are the different types of the operating system. And now let us move to the different types of operating system architecture. Operating system का architecture क्या होता है? So there would be like a single kernel based operating system, which is known as the monolithic operating system. See, it is known as the monolithic operating system, in which we have what? A single large kernel. Example was the MS-DOS. Okay, MS-DOS was an example of such system. Then we have a layered type operating system, which is divided into layered or modular type. Then we have a microkernel. Microkernel operating system, जो है, this is very one of the most secure operating system. Microkernel. Why? Because see, in microkernel operating system, we have one core kernel, and like other subsystem, or we can say other subsystem or other sub-functioning, these all are done outside the core kernel. So core kernel only handles the major functioning, and therefore it has restricted access, and therefore it is very much secure. So in a microkernel type operating system, minimal kernel use more service. Take example is Linux and QNX. Then we have the modular, or modular is also known as what? Hybrid operating system. Hybrid operating system. Hybrid operating system, such as current as Microsoft Office operating system जो हम यूज कर रहे हैं, यानी कि विंडोज, सॉरी नॉट माइक्रोसॉफ्ट ऑफिस, विंडोज, जो विंडोज ऑपरेटिंग सिस्टम यूज कर रहे हो, दैट इज हाइब्रिड. Hybrid means it is also not micro kernel, it is micro kernel also, plus monolithic also. Combination of both. Monolithic, micro kernel, and it is also preemptive. What do you mean by preemptive? Preemptive means, see, when you start one function, you are performing that job, and suddenly another job of urgent nature arises. So if you are a preemptive type operating system, so you will just hold on the execution of this job, and you will see that this job is more urgent than this job. You will go and execute this job. This is called preemptive operating system. Whereas there are non-preemptive operating system. In non-preemptive operating system, what we have, like you are assigned a job, irrespective of, like you are assigned this job, and this will take at least suppose 15 seconds to complete, and at time t is equal to 2 seconds, you got a job of very high priority or very urgent in nature, but you are not attending this job. You are first completing this job, dedicating entire 50 seconds to this, and after you complete this, you move on to this job. So such type of performance is known as non-preemptive. Okay, just remember these two words. We will be using it further, like as we move with this lecture. So we have seen the different like types of the operating system. That is, there are 6 types of operating system. That is, we have seen here batch operating system, time sharing operating system, real time operating system, distributed, multi-programming operating system, and multi-processing operating system. And in the operating system architecture, we have seen there are basically 4 types. Monolithic, that is, there is a large single kernel in the operating system. Layered, microkernel, in which there are one core kernel and there are minimal kernel, and the sub-functioning or the sub-task has been performed outside the main kernel or the core kernel. And then we have the modular, or we can say as the hybrid. Okay. So see here, one question is given that which of the operating system design is most secure? The microkernel. The reason we have already discussed. Okay. So this was the basic of the operating system. Now let us move to the process. What is the process? Let me first explain you what is the process. See, in the operating system, we have a microprocessor. What does it do? It process. What does it process? It processes different programs. See, you have the people from the computer background might be able to understand this in a much better like way, that you write some code in C or C++. That is known as a program. Okay. When program is executed, it is like executed, each line of code is being executed and the output is shown. So when program is executing, it has to interact with like maybe input output device, or interact with the memory, or like interact with the like other resources like printer, or it may use the microphone. This depend upon what types of program you are executing and what line of code is written in it. Okay. So these all resources has to be like, these all resources like speaker, microphone, or a printer, memory location, also input output access, all has to be managed by whom? It is done by the processor only. It is done by the processor only. And basically we say that the operating system manages all these operations. Okay. So when a program, we have understood what is a program. When a program, this is a program, suppose this is a program, when this is created, see, let us first see, before that, let us first see what is a process. What is a process? A process is basically a program whose process control block is created. Any program whose process control block is created is known as a process. Okay. See, what actually happens when a program is ready for execution, see, it is known as process. So when a program is to be executed, it process control block will be created, and it will be given a process ID, and it will be given as a status. First of all, there are other attributes associated with the PCB, but majorly we will understand these two only. Status. When a program is converted into process, that is, what is a process? We have understood that process, when a program is represented by the PCB, or when a PCB is created for any program, it becomes process. And process is basically meant for execution. A program is programs is some line of code which is sitting ideally in the memory, and it is not meant for execution. But as soon as you require this program and you want it to be executed, so it get ready for the execution, and this program is now called as process. Correct? So a process is represented by a PCB, that is process control block, and there are two important, rather very important parameters of this PCB. That is, one is called the process ID, another is called the status. If you are running a PC, just go to the task manager. Just go to the task manager. Just Control Alt and Delete. You will got an option to select task manager and go there. Then there will be option of details. Go to details or list. Whatever option you see, just click it. You will see that there are a large number of processes being listed, and PID is there, process ID is there, status is there, then memory, how much it is using, all these details are there. See, so these processes are running, therefore it is showing. Some status would be running, some status would be like suspended, some would be like terminated. Like this would be the status. There would be a different status of the process. Some would be in waiting. So you can see that. So I was talking about process. So a process is basically indicated by the process control block, and there would be two important things in it majorly. One is called the process ID, which is unique for each process, and another is like the process status. Now there could be a different types of status. Let us understand that. The first would be new. New means what? New means a process, means a program. Basically a program is like meant to be executed, बट अभी उसको मेमोरी एलोकेशन नहीं की गई. ठीक है, तो वो न्यू है. न्यू का मीन्स अ प्रोग्राम इज मेंट टू बी एग्जीक्यूटेड बट नो मेमोरी इज असाइंड टू इट, so therefore then it is called as the new. Okay. So when a program is created, just note it down. Just note it down, please. When a program is created, but it is not admitted to memory, when a program is created but is not admitted to memory, then it is known as its status would be new. Okay, this is first status, new. Then after that, it will become ready. When memory is admitted, the process will become ready. It when the process is ready, it means that all the required resource, that is the memory and all the required resource that that this program is like wanting for its execution, is available to it, is available to it, except what? Except CPU. CPU is not available. Rather, except CPU, all the resources are available with the process, and then the status is known as ready status. Then when once it is ready, there is one called ready queue. This is a ready queue. The process, suppose process P will be admitted in the ready queue. If the process is ready to be executed, the process will be admitted in the ready queue. Now, suppose if there are multiple process P1, P2, say P3, these are three process, all are waiting in the ready queue. Why it is ready? Why it is waiting in the ready queue? Because at that time when this process are in the queue, already the processor or the CPU is basically executing some other process. So it is not multiprocessing. So it has to be execute all the process one by one, since we are assuming that the CPU is not multiprocessing in nature. But nowadays we have CPU multiprocessing, so they process multiple process altogether. So these will be waiting in the ready queue for their turn. So all they have all the like they are in the ready queue means their status is ready. So they have all the available resource with them except the CPU. So they are waiting in the ready queue. Now, out of one, two, three process, which one will be given the CPU access first is decided by the scheduler. Is decided by the scheduler. Selects the process in the queue and assign them the CPU. And the CPU, the control of CPU to this process will be given by dispatcher. Just note this thing down, okay? Dispatcher. It gives the control of the CPU to the process selected by the scheduler. Okay. Now, suppose that this P1 is selected. Now, see, once P1 is selected, it will be given the access of CPU. So P1 is selected and it has the access of CPU. So the status would now change from ready to running. Now it is running. And when the process is running, what it will be doing? Now it will start reading each line of code. It will get the instruction, the code instruction fetch, whatever cycles are there that we study in the computer architecture, that will be happening. Then it will, when one instruction is being executed by the CPU, the address of the next instruction would be fetched. There would be like program counter in it to count. There would be registers in it. So all this thing will be there with the with the like processor or a process, basically with the process. Okay, so so it start running. So suppose while it is running, at some time it requires like some input output, or say suppose let us not specifically mention, let us say it requires some resource. It may be like any memory, or it may be like any memory access, or something like the access of a speaker or or a printer or something else, whatever resource it want to access, it want to use that resource. But or during its running some other process of high priority occurs. So what it will do, the CPU will stop executing this process, and then the status will change to what? It will change to waiting. Okay, the status will change to waiting. And then again it will resume, its status will again change to running. And then it may change its status from running to waiting, like multiple number of times. And then at the end, it will terminate. When it will finish executing, the process will terminate. So status will change to terminated. Like whenever we want to execute the program starts, it runs, it gives an output, and it's terminated. So these are the different types of status that a program is going to have. Okay? Or a process is going to have basically. So, what are the different component of the PCB that we will see? Let us first go step by step and check what are there in the notes. So we have done process. Process is nothing but a program which is in execution is known as the process, and it is represented by the process control block. So what are there in the process? There are like it contains PID we have seen, states we have seen, then we have program counter, registers, memory info, and other things are there. So these are the status first new, then it becomes ready, then start running, then waiting or blocked, and then terminated. Okay. So what stores the information about the process? It is nothing but the process control block. Which state means process is ready for the CPU? The state is ready. I think there not be any doubt in it. So we have discussed all this thing just right now. Now, let me explain you why a process need a PCB. See, why do a process need a PCB? I already told you that nowadays, suppose CPU is executing one process, say P1, it is executing P1, and while execution, it has to stop its execution and go for the IO handling or go for any other resource management or say any other process P2 arrives, which is of very high priority than P1. So it will stop executing P1 and will attend P2. So now when it will stop execution of P1, it might know what it might what it will require to know that which process I am stopping. So how will it identify with the help of PID? Then it will know the current status. What is it current status means? What is the current status means ki how many line of code I have executed. Okay, all this thing. What is it? We have some temporary variables are stored. What is it value? All this thing need to be saved because when it return to P1, it will start executing from the next line of code, and all the variables that is stored with the values has to be now like bring into the execution once again. So all this thing has to be stored. So for all this thing, so that the process could stop and then start again from where it has stopped, we required all this information, and all this information are stored where in the process control block only. So therefore, process control block is very necessary as it ensure what multi-processing. One process is executed, stop for it execution for a period of time, and then execute P2 and then execute P1. So it enables multi-processing. Okay. So obviously, what there would be six different component of the PCB. We have done the process ID. We have done the process state. Then there is a program counter. When the process is running, it basically store the address of the next instruction to be executed. So we need this. We need the CPU register also so to store the temporary variables and other like the results. So we have the accumulator also over. Just to remember that it requires CPU registers, okay, general registers such as the we have the program counter, stack pointer, or the accumulator, etc. Then it must have different types of information that is memory information, IO status information, and accounting information means how much cycle will the process take to complete. That is basically the time how much time it will take to consume, how much resource it is going to consume, what is its priority. All this thing must be known to the process. Okay, and that all this thing is stored in what? Process control block. So I hope you understand the process control block. Why do we need memory information? Obviously, you need to understand that where the instructions are stored, where the data are stored. So you need the memory instructions. You need to have the input output status information. So these are the six different content of the process control block that you need to understand and remember. So now there is another, we have a process and we have a thread. What is a thread? Thread like, see, in coding, we have like suppose especially in Java, when we have a synchronous function and then we have a synchronous function. So suppose I ask like suppose I have a work like I have a work suppose work one, then I have work two, then I have work three, and then I have work four. So now work one, the output it produces one output set output one, and this output is used by work two. But work 3 and work 4 does not depend upon the output of work 1. So these are independent. Now, when we are executing work 1 and this like this will take like suppose 10 minutes to complete. So if we follow the execution like sequentially. So work one, which is taking 10 minutes, will stop the execution of work two, work three, and work four. And work four is going to take hardly 1 second, and work three is hardly going to take suppose 10 seconds. So these jobs, which requires minimum number of time, will be kept waiting until work one is finished. So in Java, what actually is done, we assign a thread, we assign a thread. Suppose thread, you understand that thread and process are same. So we create a thread and give it to work one. So work thread one will perform the work one, and whenever output one will come, it will indicate to work two that output one is now available. You can proceed your working. And similarly, work three and work four will be assigned a different thread, and each thread will start executing independently. So, what is thread? Like in the operating system, we say that thread is a lightweight process, and it shares what? It shares code and data, but it does not share what? It does not share the like variables, different variables that it has. Obviously, it will not share. It will have its dedicated registers to store all those things. But what it can share the codes and the data. Okay. So it has a faster context switching than process. So in process, we have like all six things. We have the like six thing in a process control block. What are those things we have already seen? That is PID, status, memory information, IO information, etc., etc. So all that thing has to be saved. Also, each process is independent and have dedicated like PID and dedicated code and data. Everything is like dedicated to the process. But in thread, it shares data and code, and therefore it is faster than process. And context switching is faster. Context switching means the time in which you switch from process one to process two, and you jump from execution of thread one to thread two. You can easily jump pause thread one, execution of thread one, and you can jump to thread two. This can be done in a much faster pace than you are jumping from one process to another process. That is called context switching. Okay. So here you see what is saved during the context switching. The process control block of a process is saved. Okay. Now we will move on to another very interesting topic, that is CPU scheduling. And what is CPU scheduling? We'll see. First, let us understand what is CPU scheduling. See, I told you now, suppose there are multiple processes which are waiting in the ready queue to be executed, P1, P2, P3, P4. So now it is very important to like understand, and there is only a single CPU which will like execute all this process. So the CPU has to be scheduled in such a way that each process get executed. Now the term is the question is like which process will be executing first, which we will be executing last, and how we are going to like sort this process so that it gets the access of the CPU. So when we talk about the CPU scheduling, the following things we keep in the mind. Number one is that CPU का utilization. सीपीयू का यूटिलाइजेशन मतलब कि सीपीयू को इस तरीके से शेड्यूल करना है कि सीपीयू का ओवरहेड टाइम बिल्कुल जीरो हो. व्हाट इज ओवरहेड टाइम? ओवरहेड टाइम उस टाइम को बोलते हैं जब सीपीयू कोई काम नहीं कर रहा होता, वो आइडल होता है. ठीक है. तो पहले हमको ये इंश्योर करना है क्या कि सीपीयू का ओवरहेड टाइम एकदम जीरो होना चाहिए और इसका इफेक्टिव यूटिलाइजेशन होना चाहिए. दूसरा, थ्रूपुट. थ्रूपुट मैक्सिमम होना चाहिए. थ्रूपुट का मतलब क्या होता है कि नंबर ऑफ प्रोसेस कंप्लीटेड पर सेकेंड, ये हमारा बहुत ज्यादा होना चाहिए. तो इस तरीके से सीपीयू को शेड्यूल करेंगे. ठीक है. नंबर थ्री हम देखेंगे क्या होगा कि टर्न अराउंड टाइम T80 मिनिमम होने चाहिए हमारा. उसके बाद वेटिंग टाइम भी बहुत मिनिमम होना चाहिए किसी भी प्रोसेस का. रिस्पॉन्स टाइम भी बहुत मिनिमम होना चाहिए, मतलब इमीडिएट रिस्पॉन्स मिलना चाहिए. अब देखो, टर्न अराउंड टाइम, वेटिंग टाइम और रिस्पॉन्स टाइम क्या होता है वो हम देखते हैं ना. तो टर्न अराउंड टाइम कम होना चाहिए, वेटिंग टाइम भी कम होना चाहिए और रिस्पॉन्स टाइम भी बहुत कम होना चाहिए. ठीक है. तो क्या होता है देखो, जब एग्जाम्पल मान लो, मैं यहाँ पर एग्जाम्पल लेता हूँ. ये है, सपोज करो कि ये क्यू है हमारा रेडी क्यू. यहाँ पर प्रोसेस P1, P2, P3 आया और ये टाइमिंग t इक्वल टू 0 पे आ गया. ये टाइम t इक्वल टू 1 सेकेंड पे आया और ये टाइम t इक्वल टू 2 सेकेंड पे आया. जस्ट ट्राई टू अंडरस्टैंड. अब जब जब सीपीयू इसको अटेंड करेगा उसको हम बोलेंगे रिस्पॉन्स टाइम। अब हो सकता है कि सीपीयू विल अटेंड इट इमीडिएटली और इट मे टेक सम टाइम। तो द टाइम दैट सीपीयू टेक्स टू अटेंड दिस प्रोसेस इज नोन एज व्हाट? रिस्पॉन्स टाइम is known as response time. Now, suppose each process, it has what? It has the accounting information also. In PCB, there is accounting information where it knows how much time it will take to complete. So that is known as the burst time of a process. How much time does a process take to complete itself is known as the burst time. So suppose for P1 the burst time is 3 seconds, P2 it is 2 seconds, and P3 it is 5 seconds. So this is the burst time that it will take. So suppose P1 is allotted like P1 is allotted the control of the CPU, or it is responded at time t is equal to 1 second. Okay, understand this very like this is very important. You have to understand it. See, this process becomes ready, the status become ready at what? Time t is equal to 0, but CPU was busy somewhere. So at time t is equal to 1 second, the CPU responded to this P1. So this is called the response time, 1 second. Now, if t is equal to 1 second, it is at P1, so P2 and P3 obviously have to wait. And after how much time it will complete? After 3 seconds. So t is equal to 4 second, the process P1 will get complete. Yes or no? After t is equal to 4 seconds, the process P1 is going to complete because it will take 3 seconds as its burst time is 3 seconds. Plus, it was responded 1 second later. It arrived at t is equal to 0, but it responded at t is equal to 1, and then it will take 3 seconds to complete. So, at t equal to 4 seconds, this process will get completed. Okay. Now, this process gets completed at what? T is equal to 4 seconds. Now, suppose at t equal to 4 seconds, P2 will be attended. P2 is attended what? At t equal to 4 seconds. And it will get completed at t is equal to 6 seconds because what? Its first time is 2 seconds. It will take only 2 seconds for the completion. So t equal to 6, P2 is completed. Okay? Any doubt? I think there should not be any doubt on this. Now, for if I ask about P2, when did P2 arrive? T equal to 1. So this is known as the arrival time. Arrival time. AT. What is the response time? It was responded at t equal to 4. So this is known as the response time. Burst time क्या है इसका? Burst time 2 सेकंड का है. ठीक है, तो ये कंप्लीट कब होगा? कंप्लीशन टाइम क्या होगा? t is equal to 6 सेकंड, that we have seen over here. t is equal to 6 सेकंड, ये कंप्लीशन टाइम होगा. अब देखो टर्न अराउंड टाइम जो हमने बोला, टर्न अराउंड टाइम शुड बी एज लो एज पॉसिबल. टर्न अराउंड टाइम का मतलब सीपीयू पे कब अराइव किया गया, मतलब कब एक प्रोसेस अराइव हुआ और कब उसका कंप्लीशन हुआ. तो यानी कि कंप्लीशन टाइम माइनस द अराइवल टाइम, कितने देर तक वो प्रोसेस में रहा, कितने देर तक वो प्रोसेस में रहा, फॉर हाउ लॉन्ग इट हैज स्टेड इन द प्रोसेस, दैट इज नोन एज द टर्न अराउंड टाइम. तो कंप्लीशन हुआ एट t इज इक्वल टू 6 सेकंड पे और इट अराइव्ड एट व्हाट? t इक्वल टू 1 सेकंड. सो इट वुड बी लाइक 6 minus 1, 5 सेकंड. This is nothing but turn around time. Very important, just note it down. Okay. So you see, this process actually required how many seconds? 2 seconds to complete it. But for how many seconds it has remained in the process? 5 seconds. Yes or no? Yes, for 5 seconds it has remained in the process. So what is the waiting time? How much time it has waited for its execution to get completed? That is known as the waiting time, WT. So it is nothing but the total time it has spent in the process, that is turn around time, minus the burst time, that is actual time it required for the completion. The difference of 2 will be the waiting time. So in this case, what? 5 minus 2, this is equal to 3 seconds is the waiting time. So this waiting time should be very less. CPU should be scheduled in such a manner that turnaround time means very less. It is very close to burst time. Matlab, the time that you require to complete, only for that much time you had to be in the process. You did not have to wait in the process. And if TAT become equal to burst time, then what would be the waiting time? That equal to 0. Waiting time is nothing but TAT minus burst time. So if your burst timing, or sorry, turnaround time is very near to burst timing, that means waiting time will be equal to 0. So all these three terms terms we have to understand, and we have to ensure that we schedule the CPU in such a manner that TAT become less, WT become less, and response time become less. Okay. Now we will see the different techniques that we will use for the CPU scheduling and what are the advantages and disadvantages. Okay. So this is what I have mentioned over here. It is used for multi-process complete for CPU. CPU scheduling criteria क्या होता है? CPU utilization, throughput, turnaround time, waiting time and response time. Okay. So which criteria is best for interactive system? Interactive system में response time criteria is the best. Why? Because in interactive system you don't want waiting time to be very high. You want immediate response. ठीक है? So response you should be like responding immediately whenever process is ready to execute. Just execute it. Do not let him wait. So whenever you are designing an interactive system, you have to ensure that the response time is very less. Immediate response is provided. Okay. So if this is done, let us go to the CPU scheduling. CPU scheduling. How do you do that? And what are the different algorithms available? So the first algorithm that is available is first come, first serve. And then this algorithm, if we in this algorithm there is a drawback, that is what it is convey effect is a drawback, and it is applicable for both for non-preemptive simpler queue order. So let us understand first come, first serve. Let us understand all these different type of like CPU scheduling that will go to the nodes and we'll see what is there. See, number one is first come, first serve. In this is the ready queue. The process which will come first will be executed first. And there it is for non-preemptive. Non-preemptive means what? Non-preemptive means once any process is started, if you start P1, you have to complete P1. You cannot interrupt it in between. You cannot stop it in between and go to any other process P2. You have to complete P1 in its entirety. You terminate that process, then you go to the next process that is non-preemptive. But if you talk about the preemptive, what we'll say preemptive means P1 is there, you can anytime you can stop this process, go to the P2. Anytime you want to stop P2, go put it on waiting, go to P3 or P1, whichever process you like. So in the first come first serve, what we will happen, those process will come first, will be served first by the CPU. It's simple queue like structure. We have seen the queue. Those who will be ahead in the queue will be given the priority first. So the first come, first serve, there is a convoy effect. What is a convoy effect? Suppose this P1 is required 10 minutes to complete this process. P2 required 1 minute and P3 required only 10 seconds. So even though P3 can be completed like in very less time, it has been kept waiting for like how many minutes? 11 minutes. ठीक है, it is kept waiting for 11 minutes. P1 will take 10 minutes, P2 will take 1 minute. So total after 11 minutes, this process will execute. And suppose this process is requiring only 10 seconds to complete its execution, but it has waited how many minutes? 11 minutes. That means 660 seconds. So this is the disadvantage of the first come first serve, and this disadvantage is known as what? This disadvantage is known as the convey effect. Okay. Then we have the second algorithm that is known as the shortest job first. Here, shortest job first means the execution, and this will be like both preemptive also and non-preemptive also. Preemptive also and non-preemptive also. So in this algorithm, what we achieve? We achieve the minimum average waiting time. Minimum average waiting time. This algorithm gives minimum average waiting time. Okay. So shortest job first means you are executing P1, okay, but at that time P2, P3 was not there. So when you start execution, you saw that in the PCB there is an accounting information which state that 10 minutes will be required. Suddenly P2 arrives. Just in after like 1 second or 2 seconds, P2 arrives. You saw that oh P2 required 1 minute and this will require 10 seconds. You stop execution of P1, you move to P2 and start executing P2. Now P2 when there is information in P2 says that it will like require 1 minute or 60 seconds to complete. and then after like few seconds, like 3 4 seconds, another process start. I want execution, I want the control of the CPU, and you saw that it requires only 10 seconds. So you will stop executing P2 and start executing P3 because it is the shortest job. And then you first complete P3, then you go back to P2, complete P2, then you jump back to P1 and then complete P1. This is shortest job first, and it will give what? Minimum average time. Minimum average waiting time. This process will give minimum average waiting time. Okay, the third is round robin. Round robin. Round robin means what? You have P1, you have P2, you have P3. Okay. So these are the three processes in the ready queue. The CPU says that, okay, I will define one time quantum. I will define one time quantum, say 10 second. And for each 10 second, I will give chance to P1. If it completes its execution in 10 seconds, well and fine. Otherwise, I will jump to P2, give it another 10 seconds to P2. If within that 10 seconds, if it's complete its execution, okay, well and fine. If not, I will go to P3. And again, I will see whether P1 is complete or not. So I will move again to P1, again P2, P3, and this process will continue. And this is known as the round robin. So see, this is preemptive or non-preemptive? Is this preemptive or non-preemptive? So it is preemptive because it is stopping the execution of the process, jumping to the next process. Okay, so it is preemptive. So why this process is important? Is important when like we have the systems that work on the time sharing. For those systems, this type of scheduling is very important. Time sharing system, we can say. Time sharing system, this type of scheduling is very important. Okay. Then the fourth type we have the priority scheduling. Priority scheduling. So priority scheduling is very simple to understand. Like you have P1, P2, and P3, and there is information about the priority of each process. Suppose it is having the priority of 4, it is having a priority of 3, it is having the priority of 2. The process with the highest priority will be executed first. Okay. And the process with the lowest priority will be executed last. Now there would be a problem. I think you have identified it already. Now suppose there is this P1 started executed, and while it executing completed, it moves to P2 and it start executing. While again executing P2, there is another process start comes in the ready queue, which is P4 and having priority greater than 2. So now it will not go to P3, it will go to what? P4 because its priority is more than 2. So suppose P4 is executing, then suddenly another process comes P5 whose priority is again greater than 2. So it will again execute P5. So we can say that भाई प्रोसेस P3 तो भूखा मर जाएगा भाई, इसको तो सीपीयू मिलेगी ही नहीं कभी प्रोसेस के लिए. सो इसमें एक प्रॉब्लम है और उस प्रॉब्लम को एग्जैक्टली व्हाट वी से एज दिस स्टारवेशन प्रॉब्लम. एग्जैक्टली इसको यही बोलते हैं, दिस इज द स्टारवेशन प्रॉब्लम, कि द जॉब और द प्रोसेस विद द लीस्ट प्रायोरिटी will have to wait for a longer period of time. And it may also happen that it will wait forever. If there is a ready queue is never empty and it has process which is priority is greater than the waiting process, then this process will never going to run. So this is the starvation process. So what could be the possible solution? Yes, there could be a possible solution to this, and that solution is known as the aging. इसमें क्या करते हैं कि भाई आप इसकी प्रायोरिटी को बढ़ा दो. आप देख रहे हो कि P3 जो है पिछले 10 मिनट से होल्ड पर ही है. तो क्योंकि जितने भी प्रोसेस आ रहे हैं उन सबकी प्रायोरिटी क्या है? ग्रेटर देन 2 है. तो आप इसको बढ़ा के 4 कर दो या 5 कर दो, प्रायोरिटी बढ़ा दो भाई टाइम के साथ. आप इमीडिएटली 5 मत करो, पहले 3 करो. देखो भाई 3 पे भी आप एग्जीक्यूट नहीं हो रहा, 15 मिनट्स हो गए, तो इसको बढ़ा के 4 कर दो. सडनली कभी तो ऐसा होगा ये एग्जीक्यूट हो जाएगा. तो दैट इज कॉल्ड द एजिंग. ओके. नाउ लास्ट में एक और प्रोसेस होता है, प्रोसेस नंबर 5, जिसको हम बोलते हैं मल्टी लेवल क्यूइंग. क्यूइंग मल्टी लेवल क्यूज में क्या होता है? देखो, प्रोसेस को वी कन्वर्ट इनटू स्मॉल स्मॉल प्रोसेस. वन प्रोसेस इज कन्वर्टेड इनटू स्मॉल स्मॉल प्रोसेस. एंड जो रेडी क्यू है, रेडी क्यू को भी हम डिफरेंट डिफरेंट क्यू में डिवाइड कर देते हैं और हर क्यू को अलग से स्केड्यूलिंग करते हैं. ठीक है, हर क्यू को अलग से स्केड्यूलिंग करते हैं. सो दिस इज कॉल्ड एज द मल्टी लेवल क्यूइंग. once the process is break down into smaller process, and also the ready queue is divided into variable small ready queue. So this is called the multi-level queuing. ठीक है. So let us go to the let us do one example so that you will understand this thing much better. Then we will go and see what is there in the theoretical part. So suppose I'm saying that we have suppose five process. Let us write over there. Suppose we have five process P naught, P1, P2, P3, P4. Understand this thing very clearly. And let us understand, let us have like this is the different parameters. So arrival time, let this be the arrival time, which will indicate that when the process has arrived, then this will be the burst time, that how much time it will require to complete. Then let us have the completion time for non-preemptive, and then we have the completion time for preemptive, preemptive operating system or preemptive processing. Then we have the turnaround time for non-preemptive NPE. Then we have the turnaround time of preemptive execution. Similarly, we'll have waiting time for NP, non-preemptive. And waiting time for preemptive execution. Okay. So now suppose I will take randomly that let this be the this arrives at time t is equal to 1 second, this at 2 seconds, this at 3 seconds, this is 4 seconds, this is 5 seconds. And let the burst be given as 7 cycle, 5 second, or let us take 1 second, 2 second, 8 seconds. So let us start. See, listen to me very carefully, so you will understand the shortest job first algorithm and the difference between the non-preemptive and preemptive. So this is non-preemptive, means once the job is started, it has to be completed. So when the CPU sees CPU is not executing any process, so it is ready to execute the process. As soon as the P naught arrives, okay, at time t equal to 1 second, it will start executing it. How much time it will take? 7 seconds. So completion time for it will be 8. Okay. Then by the time 8 second, it will now look for which one is the shortest. And see, at the end of 8 second, all this P1, P2, P3, P4 has arrived. Okay. So it will look that which process is to be executed on the what process it will what for system it will follow. It will see the burst time, shortest job. So it will find that okay, P2 will be addressed first because it will only require 1 second. So P2 will get completed at 9 seconds. Then it will go to P3. It will get completed by 11 seconds. Then it will move on to P1. It will get completed by 16 seconds. And then it will get move to P4 and see that it will get completed by 24 seconds. Okay. So in this is a non-preemptive. Now for preemptive, let's say that for preemptive, at time t equal to 1 second, P naught arrives and CPU is ready to execute it, so it start executing. It executed. So from 1 second, it continue execution for another 1 second at 2 seconds. It check whether at 2 seconds any process is there in the ready queue, which has the shortest than this P0. It check at T2, which arrives, the process P1 arrives at time t is equal to 2, and its burst cycle is 5 seconds. 5 seconds, so it is shortest than P0. So it will what it will do? It will stop the execution, and then it will come to P1. It will start execution. For 1 second, it will execute P1, and at end of 3 seconds, it will see whether any other process has arrived in the ready queue. It will check that at 3 seconds, P2 has arrived. So what is the execution cycle requirement? Only one. So it will see that the current process which I am executing is requiring 5 seconds, and this P2 is requiring 1 second. And since this is preemptive, that means it can stop execution in the middle also. So it will stop execution and it will go to P2 and execute this. So it will take only one cycle. So after 3, it will add one more second, 4 seconds, and at 4 seconds, it will get completed. But it will check at 4 seconds any other process has come. So at 4 seconds, it will have to basically, if no process was there, it will go back to P1 because out of P0 and P1, P1 is the shortest one. But at the same time, at 4 seconds, P3 arrives and it requires only 2 seconds. So it is shortest than the P1, which require 5 seconds. So it will go to P2 and execute. So it will execute for 5 and see whether at the end of 5 seconds any other job arrives. Yes, P4 arrives, but it has execution total cycle requirement is 8 cycles or 8 seconds. So it will see that the current process which I am executing is actually shortest than what has arrived. So it will continue executing that, and at the end of 6 seconds it will complete that. Okay. At the end of 6 seconds, it will complete that. When this process is completed, it will see which is the shortest. If it will check if any other process is there. In our case, there is no other process, so it will check which is the shortest now. It will go to the P1, it will check that this is the shortest. So after 6, it will give 5 seconds to this one, this process. Okay. So already for 1 second it has completed, only 4 seconds is required. So at the end of 10 seconds, this will complete. Now, when P1 is completed, it will go to P0. It required only 7 seconds. It will require 8 seconds. So out of 7 seconds, already 1 second it has used it. So 7 seconds is remaining. So for 7 seconds, 1 second it has used, 6 seconds is remaining. So at the end of 16 seconds, it will complete. See, this is basically what? This is time t equal to 2 seconds. But actual time it has taken is 1 second only. So at the end of 16 seconds, this will complete now. It will move to this process P4 and it will see that it will require 8 seconds. So at the end of 24 seconds, it will complete. So see here what we have done. Total time for execution was same, but we started with P0, then we moved to P1, then we moved to P2 and complete P2 first. Here what we did, we complete in non-preemptive, we completed P0 first. So now we have the data. We can complete the other table. Like we have the formulas with it. So turnaround time, I will show you once. Turnaround time will be what? It will be like the completion time minus the arrival time. So here it will be like what? 15 seconds. For NP, how much? Completion time is 8, arrival time is 1. So it will be 7 seconds. And for preemptive, this completion time is 16 and arrival time is 1. So it will be like 15 seconds. What will be the waiting time? The total time, that is turnaround time minus the burst time. So for non-preemptive, it is burst time is how much? 7. So it does not wait. Obviously, it does not wait in the case of non-preemptive. Why? Because it is non-preemptive. Once P0 is started, it has to complete. So its waiting time is 0. But in case of preemptive, what is the waiting time? Total turnaround time minus burst time, 7. So this will be how much? 15 minus 7, that would be 7. Similarly, you go on completing the rest of the values. I hope you get a clear idea of what is the shortest job first algorithm and what are the different turnaround time, waiting time, and what is the main difference between the preemptive and non-preemptive execution. If that is clear, let us quickly go through the notes and check what is there in it. So shortest job first, it gives the minimum average waiting time, and it can be like preemptive and non-preemptive that we have seen just now in the below numerical. Then we have the round robin. Preemptive uses time quantum, good for time sharing system. Okay. Now, just note that in the round robin, we have we are using time quantum. So the performance will depend upon t. Like if t, like how much time you are giving to the where is that we have understood? Hmm. This like 10-second quantum was decided. So how much time quantum you are deciding will actually decide the performance. Suppose if you take very very large t, that means you give it to like t quantum second, you give it to p1. After that you will switch to p2. But if t is very very large, that means that p will continue execution for a large time. Then it will become what? It become like first come first serve only. The process which arrived first, you are getting executed first. If t is very very large, it behaves like first come first serve only. And if t is very very less, then if t is very very less, suppose 1 second, then 1 second में क्या होगा? P1 को पॉज करना पड़ेगा, इसका सारा जो करंट स्टेटस है वो सब सेव करना पड़ेगा, और उसके बाद P2 में आना पड़ेगा, फिर 1 सेकंड के बाद P2 को पॉज करना पड़ेगा, सारा करंट स्टेटस सेव करना पड़ेगा और P3 पे जाना पड़ेगा, और ये चीज रिपीटेडली करनी पड़ेगी. तो मतलब क्या हम कह सकते हैं कि कॉन्टेक्स्ट स्विचिंग जो होगा, कॉन्टेक्स्ट स्विचिंग क्या होगा? बहुत बहुत फास्ट होगा. Getting my point? So this is the disadvantage of like the round robin. It is good for the time sharing system, no doubt in it, but it has disadvantage because performance depend upon what? The quantum of time selected. Then priority scheduling. Basically, there is a starvation problem that we have seen. Then we have multiple level queuing in which process divided into classes and each queue has its own scheduling algorithm. Then we have some question on it that which algorithm suffers from conveyor effect, that is FCFS. We have seen it first come, first serve. Which scheduling algorithm gives minimum average waiting time, that is shortest job first. Which algorithm is best for time sharing, that is round robin. And which problem occurs in priority scheduling? तो priority scheduling में क्या problem आती है? Starvation, and we have seen the like the starvation. What is starvation? Okay. So with this, we have completed the unit 1 and unit 2. So we will stop here and we will begin unit 3 in the next class.